before and after puzzle. So for this problem, we are given a list of phrases, and we're going to generate a list of before and after puzzles. So the idea is that we are given this kind of a list, writing code and code rocks. Yeah, so this means we're gonna choose a phrase. For example, we're gonna choose the first phrase. It's gonna be writing code, and then we're gonna find any other phrase inside the phrases array. Because I not equal to j, it means we must choose another one. It's gonna be a code rocks. So if the last word of the current phrase equal to the first word of the next phrase. So for example, this code equal to this code, so the final one going to be writing code rocks. Yeah, we just need to connect them together, and we want to return how many such kind of links or how many such kind of connections, and the final answer would be distinct. That means if there's a duplicate, we need to remove the duplicate, and also we need to sort it in lexicographically order. So this means we're gonna order it like ABC in lexicographically. Yeah, let's just check the second example. I'm not trying to find all of them, but just find a few. So for example, a chip of the old. Let's find where is a chip of the old block, and then we're gonna find a block. So here is block party. So it's gonna be a chip of the old block party. Yeah, we just need to find as many as we like, and there's gonna be no duplicate, and it's gonna be sorted in increasing order by the letter. And let's just check what is the phrase length and the phrase I.length. It is 100 and 100. It seems okay that we can solve this problem by using the brute force. So the brute force idea is that, so first of all, we're gonna check the length of the phrase. So normally it is 100. So this 100 means the time complexity is gonna be n log n. But as we have the length of the phrase, so we need to consider it together. Yeah, so we need to check the time complexity together with the length of the string. Yeah, so for example, our length of the string gonna be n equal to 100. So if it is just the numbers, we are okay. So the time complexity for the sorting gonna be n log n. But currently, for each of the phrase, we have a length of 100. Yeah, so this means the time complexity gonna be 100 times 100, but this like 10 to the power of 4 times log 10 to the power of 4, but it's gonna still be a small number. That is why it still works. So that is why we can still use the brute force to solve the problem. Yeah. So for the brute force idea is that we just need to enumerate all the possible combinations, and then we're gonna put it inside a set, and we're gonna sort it and get the final return. Now let's just use the brute force to solve the problem. So I'm gonna prepare a result. So the result gonna hold all the combinations, but I want to get the string and to split it and let it become an array, and I'm gonna put it inside the result array. So I want to check each of the phrases. So for phrase inside the phrases, I want to put it inside the result array. So I'm gonna append it, and it's gonna be the phrase dot. I'm gonna split it with empty string. So currently this result gonna be an array. Let me just print out what is the result looks like. Yeah, so this is gonna be the final result. As we can see, it's gonna be something like each of the words. We're gonna split the phrase into the word. Now we can compare with the last word in the current array to compare the first word in the next array if they are not equal. So we're gonna just check that, and we're gonna put the possible result in an answer, and finally we're gonna return the answer. So let me just delete the print, and I'm gonna prepare an answer array. It's gonna be empty, and n gonna be the length of the result. So we're gonna check it. So for I in range n, and for j in range n, So if I not equal to j, and the last letter is gonna be result I minus 1 equal to the current one, it's gonna be result j 0. So this means we can put it inside the answer array. So the answer gonna append. So it's gonna be, we're gonna draw them together. We're gonna draw the array together. So it's gonna be the result I2 minus 1 plus result j. So this means we're gonna just remove the last one. So for example, we're gonna remove this code, and we're gonna combine the second one, and we're gonna combine them together. Now for the answers array, we just needed to turn the answer into a set of answers, and after that we're gonna sort it. So we're gonna turn it into a set, and then we're gonna turn it into a list. Now we're gonna sort it. Yeah, or we can just use a set maybe for this. Yeah, yeah, I think it's okay if I use an array. Maybe I'm gonna use a set. So this is gonna be an empty set. So here gonna be the end, and then the answer I'm gonna turn it into a list. And finally, I'm gonna return the answer. So after I turn this answer into a list, I can sort it. So the answer dot sort, and finally I can return the answer. Yeah, so here for I in range n, and we're gonna check. Yeah, so now let me check what happens from here. As you can see, it is connected, but my answer should not be connected. I connected all of them together. It means there's something wrong from here. Yeah, actually from here it should be an empty string. Draw all the word, otherwise it can't be connected. Now it will not connected. Now it will be the string like this. Yeah, writing code works, and for others, and we just enumerate all the possible cases. Yeah, so I think that's gonna be the solution for this problem. I don't think it is too hard, and basically it is just brute force. Thank you for watching. See you next time.